Hello students, welcome to my lecture on computer graphics. Today I will cover the topic ellipse generation algorithm. I am Shravani Kundu, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology. As you know that ellipse is another important object for computer graphics. So while we are drawing any object, any shape, we need the ellipse. Like circle, ellipse is also symmetric in nature. So if you see, this is an ellipse. Now, for this ellipse, this is the, consider this is the center point of the ellipse. Unlike circle, the property of the ellipse has, as the circle has one center, circle can be identified by the center and the radius. Similarly, the ellipse can be identified not only by the center and radius. Other than that, ellipse has two different types of radius. They are called the major axis and minor axis. So as you can see over here, so for this particular diagram, so if I draw a line through the center, this is probably the center of the ellipse. So if I draw the line through the center of the ellipse and which is parallel to x-axis. Why it is parallel to x-axis? If we draw the axes like this one, so this is our y-axis and this is our x-axis. So this line which is passing through the center of the ellipse, this line is parallel to the x-axis. So a line which is parallel to the x-axis is called the major axis. Similarly, we will also draw a line which is parallel to the y-axis, that is called the minor axis. So here what we can do, we can also draw a line like this one. So this line is parallel to the y-axis. And another important thing is that, so what we can say over here, so this is our, let me write down, it is our x-axis and this is our y-axis. Now in this figure, you can see this line which is parallel to the x-axis, this line and which is passing through the origin. So this is my origin, this particular section is my origin. So the line which is passing through the origin, this line is called the major axis. So this is called the major axis. And the line which is passing through the origin and which is parallel to the y-axis, this is called the minor axis. Okay. Minor axis. Now, apart from that, you can see the major axis intersect with the arc of the ellipse with a point, and this point is called the vertex. So here through this point, through this point, the major axis intersect with the ellipse. So this point is called the vertex. So it is called the vertex. Similarly, the minor axis, which is here, so this minor axis also intersects the perimeter or the arc of the ellipse on a point, and this particular point is called the co-vertex. So this is a point where it intersects. So this point is called the co-vertex. Okay. Now, apart from that, there is also some points. So there is some points over here. So this point is called the focus. This is called the focus of the ellipse. So similarly, there is also a focus of the ellipse, and if for this particular ellipse, if it is the center is xc and yc, so in that case the focus will be xc plus c comma yc, and in this case the focus will be xc minus c comma yc. Clear? So this is the overall properties of the ellipse. And and some important points again I want to discuss, that what will be the coordinate for the vertex. So if it is the major axis and if this entire length, so that means this particular length from this to this up to this, if this length is designated by b, sorry, consider it is a, if I designated this length as a, then this particular point is nothing but xc plus a comma yc. Okay, and when this origin will be shifted, when the center of the ellipse will be shifted to the origin, then for in that case this point, the points coordinate of the vertex will be a comma 0. Similarly, for the, what will be the vertex for the what is the coordinate for the co-vertex? The coordinate for the co-vertex will be, this is the xcyc, this is the center point, and assume the distance of the minor axis is, the length of the minor axis is b, and here the length of the major axis is a. So what we can do, we can write it like this will be my xc will be as it is, it will not change, but the y coordinate will change and it will be yc plus b. Fine. And similarly, when this center will be shifted to the origin, then this particular point of the coordinate of the co-vertex will be this will be 0, the value of x will be 0 and the value of y will be just b. So its point will be 0 comma b. So this is all about the basic properties of the ellipse. Now we will write down the equations of the ellipse. Fine. So the equations for the ellipse are, which is where the major axis is parallel to x-axis. So here the major axis is parallel to x-axis. So if the major axis is parallel to the x-axis, in that case the equation of the ellipse will be x square by a square plus y square plus by b square is equals to 1. Fine. And there is also another equation. If the major axis is parallel to y-axis, in that case, the equation of the ellipse will be x square by b square plus y square by a square is equals to 1. So here in this case, the major axis is parallel to x-axis, and in this case, the major axis is parallel to y-axis. Fine. So that is all about the basics of ellipse. Now, what we will do, we will go in details that how the ellipse can be generated using the program. So as you know, in case of the midpoint circle drawing algorithm, based on the midpoint, we will calculate the y points and the x point also. And using the x value and y value, we can put the points, and based on one x and y value, we can generate the points for other 7 octants and we can draw the ellipse. The same thing is true for the ellipse also. So as we can draw the circle, that means using one point I can generate the other 7 points. Similarly, in case of ellipse, using 1 point I can generate the other points also. So first we will see what is the basic features of the ellipse. So now I am considering an ellipse like this one, and assume its center is passing through the origin. Okay, its center is the center of the ellipse belongs to the origin. I am drawing an ellipse whose center is at the origin. So whose center is at the origin means, this will be our x-axis and it will be our y-axis. Now the center of the ellipse is 0, 0 and this is the major axis, which is A. This entire length is A. This entire length is B. Okay, so this is the major axis and this is the minor axis. Now, what we can do here, you can see if I divide the ellipse, as you know that there are 4 quadrants. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So the curve, which is the arc, which is belongs to the quadrant 1, if I divide the arc by a line which is passing through the origin, in that case we will get two regions. One is called the region 1. So this is called the region 1 and this is called the region 2. Okay. Again I am repeating, we have an ellipse. The arc belongs to the first quadrant. If we draw a line which is passing through the origin, then that line will intersect the curve on a point, and that point divide the entire arc in two parts. The first part is known as the region 1 and the second part is known as the region 2. And you can see one important thing, that in case of region 1, the changing of the x is not as per the changing of the y. That means the rate of changing of the x. So the rate at which the x is changing, the y is not changing at the same rate. Rather, the changing of the y is faster than the changing of the x in case of region y. Again, I am repeating, in case of the region 1, the changing of the x or the changing of the y is not as fast as first as the changing of the x. Again, in case of region 2, it is just the opposite. So if you consider only this part, so if you consider only this part of the slope, this part, if you consider only up to this one, this section of the ellipse, you can see what is the starting x value. The starting x value is this point and the ending x value is this point. Whereas the starting y value is this point, the ending y point is this point and the starting y point is this one. What I basically wants to say, in case of region 2, note it very carefully, what is the rate of changing of x. The x starts from this point and ends at this point. So the change of x is very small. Whereas in case of, say, for the same region 2, the change of y is very wide. That means here you can see the starting point of the y is this one and the ending point of y is this one. So change of y is so much. Again, if you consider the same thing for the, region 1 also, so this is our curve. Okay, this is the part of the curve of the region 1. Now, if you draw a line like this one, okay, here you can see what is the starting value of x. The starting value of x is this one. That means this 0. And this is the ending value of the x. So this is the ending value of the x. So x will change from this to this. This is the range of the x. X will start from 0 and end will at this point. Whereas if you consider the y, y will change. So y will start from this point, but y will end at this point. So this is the portion where the y will change. So you can see, if you measure the length, that then in that case the change of y, that means the change of y and if you compare both the change of y and the change of x, you can see the change of x is more faster than the change of y. So this is the two important features for the region 1. So again I am repeating, in case of region 1, the change of x, that means the increment of the x is more, x varies more compared to the value of y. In case of region 2, the x varies less compared to the value of y. So for the region 2, the increase of x is more compared to the value of y, but in case of region 1, the increase of value x is more compared to the y. So for the region 2, y increases more. The rate of change of y is more compared to the x, and for region y1, the rate of change of x is very large compared to y. So these two is the very important features. You have to understand it first, otherwise you can't understand how we can derive the equation. Fine. So what we have to do, we have to derive the equation for both region 1 and region 2. So that means we have to derive the decision parameter for the region 1 and the region 2. Clear? Now, there is another important thing. If you draw a slope, so if you draw a slope like this one, if you draw a slope like this one, if you draw a line segment like this one, so here you can see this line segment will touch the point, this particular point. So where in this point the curve in the first quadrant is divided in two halves. Okay, so based on this point, from where the curve is divided into two parts, on this point, if I draw a tangent, then that tangent indicate, the value of the tangent indicate that when we have to stop to generate the points of the region 1 and when we have to start the points of the region 2. Fine. So again I am repeating, so if I draw a tangent which will pass through a point, which point? The point which will divide the curve of the quadrant 1 into half, that means region 1 and region 2, and this value of the tangent decide while I have to stop the region 1, while I have to stop the generation of the points for the region 1, and while I have to start the generation of the points of the region 2. Okay. Now another important thing is that if you can calculate the points on the region 1, definitely you can calculate the points on the region 1 of this quadrant. You can calculate the points of the region 1 for this quadrant and this quadrant also. So once you can find out the points for this particular quadrant, you can also find out the points for this one, and this one, that is quadrant 2, quadrant 3 and quadrant 4. Similarly, once you can find out the points of the region 2, the curve of the region 2, then you can compute the points on the region on the quadrant 2, quadrant 3 and quadrant 4. So that means we can generate the entire ellipse. Fine. So this is the basic features, basic consideration while we will draw the points, while we will find out the points for the region 1. So now let us write the equation for the ellipse. The equation of the ellipse is x square by a square plus y square by b square equals to 1. Okay. Clear? Now if I simplify this equation, I can write it x square b square plus y square a square minus a square b square equals to 0. Fine. Now how we can find out the what will be the equation of this tangent? We have to find out, we have to calculate the first order derivatives with respect to x, because you know the slope of this straight line, the line which is passing through this point, the slope of this line is nothing but dy dx. So what we will do, we will derive this equation with respect to x. So if I derived it, it will be like this one: x square b square y square a square minus a square b square is equals to 0. So if you do the first order derivative, so what you will get? You will get 2x b square plus 2y a square dy dx is equals to 0. That indicates that what will be the value of dy dx? The value of dy dx is minus 2x b square divided by 2y square. So this is the value of the tangent for the line which is passing through the points which divides the entire curve of the first quadrant into two regions, which is called the region 1 and another is called the region 2. Clear? So this particular value we will require to decide while I have to stop the generation of the points of the region 1. Now, so we will take this one and we will move it aside. We will keep it because this we will require for our future reference. And we need these equations. So we don't need those further processing. So I am removing it. Fine. Now, as you know, for the as you have seen for the circle generation algorithm, so if those are the pixels, so if I have a set of pixels, then how I can take the decision that which pixels I have to illuminate and which pixels I don't need to illuminate. Okay. So consider this one. In this case, you can see that this point, this one is yk and the next one is yk minus 1. And this is xk and this one is xk plus 1 and this one is x of k plus 2. Okay. xk, x of k plus 1 and x of k plus 2. Now I am generating the equation decision parameter for the region 1. So what we are doing? We are generating the decision parameter for the region 1. So now we are working for the region 1. So if you know that if there is a curve and which is passing like that, okay, this is the midpoint. This point is called the midpoint. And you know, for this midpoint, what is the x value? X value is x of k plus 1. And what will be the y value? As you know, for the same as the circle generation algorithm, if this what is the entered distance? This is yk, this is yk minus 1. So this entered distance is 1 unit. Fine. So as the entered distance is 1 unit, so what I can say, what is the point? So I have to go yk unit. This is enter yk. From the yk, I have to minus 0.5. This entered distance is 1. So this part is definitely 0.5. So it will be, the y value will be yk minus half. Okay. So this is the x coordinate and y coordinate for the midpoint. Okay. Now, what we will do first, we will generate the decision parameter for the kth iteration. So the decision parameter for the kth iteration will be nothing but, based on this equation, this, let us say it is equation 1. So based on the equation 1, what I will do, I will replace this x by xk. So assume that the first one, this particular cell is already illuminated. Okay. So this cell is already illuminated, and now for the xk plus, for the value of x which is at k plus 1, I have to decide whether I should illuminate the yk pixel or yk minus 1. That means whether we should illuminate the upper pixel or the lower one. That will that I can decide based on the value of the midpoint. So the value of midpoint is this one. Very simple logic. Put the midpoint on the equation of the ellipse. If you get the value is less than 0, that means the midpoint is inside the circle. If the value is greater than 0, the value is out, the midpoint is outside of the circle. So as you know, so if I say that this is the equation of the circle, and which is function of xy function, if the function of xy is the equation of the ellipse, not circle, function of xy is the equation of the ellipse, then if I put any xy in that equation, so what will be my function of xy? My function of xy will be nothing but x square by b, x square b square, y square a square minus a square b square. Now if you put any value xy on this equation, and if you get that function of xy is greater than 0, that means the point is outside of the ellipse. If it is less than 0, that means the point is inside the ellipse. And if it is equals to 0, then the point is on the curve of the ellipse. Fine. So based on the logic, we will take the decision, we will find out the pk. Now how to find the pk? So we will put this midpoint on the equation 1. So if I put the midpoint on the equation 1, what I will get? I will get it x square. So it will be xk plus 1 whole square, b square plus y square. What is yk? Y square is yk minus half square, and then a square, then minus a square b square. Okay. So if you see that this is the equation for the region 1, and if you simplify it, what you will get? You will get, instead of writing xk plus 1, I can write it xk plus 1, because by adding 1 in the xk value, I can get x of k plus 1, b square y of k minus half whole square, a square minus a square b square. So say this is the equation 2. Fine. Now we will, based on the equation 2, we will find out the decision parameter for the k plus 1th term. So very easy. What you have to do? So here this k will be replaced by k plus 1. So it will be x k plus 1 of plus 1 square, b square plus yk will be replaced by y of k plus 1 minus half a square b square. Clear? And now we can again simplify it. I can write this x of k plus 1 is just like xk plus 1 whole square plus 1 and then the entire square. Sorry, not, I just made a mistake. it will not be whole square. K plus 1 will be replaced by x of k plus 1, then plus 1, and this entire whole square, then b square plus this parameter can be expanded like this one, minus 2 of y of k plus 1 plus 1 by 4 a square minus a square b square, and then we can write it xk plus 1 whole square plus 2 of xk 2 of xk plus 1 plus 1, okay, and then plus y square k plus 1 minus 2 of yk plus 1 plus 1 by 4, and along with that there is the parameter b square, there is 2b square, okay, this will be also b square, this is a square, this is a square, and this a square by 4 minus a square b square. Fine. Okay. So this is the term for k plus 1. Let us say this is 3. Now, if you subtract, if you find out the difference between p of k plus 1 minus pk, then you can subtract these two parameters. If you subtract this equation 3, that means if you perform 3 minus 2, what you will get? After performing 3 minus 2, after performing 3 minus 2, you will get this one, 2b square xk plus 1 plus y square k plus 1 minus y square k a square minus a square y of k plus 1 minus yk plus b square. Fine. So this is the value you will get if you subtract pk plus 1 minus pk. So what you can do now, you can write down, you can say p of k plus 1 is nothing but pk plus 2b square. Fine. We can write x k plus 1 is nothing but x of k plus 1th iteration plus, we cannot write yk plus 1 as yk plus 1, because yk plus 1 is the y value for the k plus 1th iteration. So what will be the y value? From the figure you can see this is our k plus 1th iteration. So in our k plus 1th iteration, the y value can be either yk and yk minus 1. So again I am repeating the same thing, that don't get confused. Don't say that yk plus 1, that means yk plus 1. It is not like that. Yk plus 1 means the y value for the k plus 1th iteration. So it can be either yk or yk minus 1. So we will keep it as it is, a square minus y of k plus 1 yk a square plus b square. Okay. So this is our final decision parameter, and based on this decision parameter we can decide that this is our final decision parameter, say it is equation 4. So based on this decision parameter we can decide what will be the points for on the circle for the region 1. Make it clear, this decision parameter is only applicable, this decision parameter only will be used to find out the points for the region 1. And how it is we can find out? We can find out that we know, if we know the value of pk. So okay, before that we do one thing, we find out the initial decision parameters. The initial decision parameter will be p0, and you can see from this image p0 means this one. the first point, the point belongs to here, the point belongs to at this position. Here I have to find the initial decision parameter P0. So if I want to find out the initial decision parameter P0, so in that case, what is the value? What is the value? Value is, this is the y-axis. On the y-axis, all the x value is 0. So the value is 0 comma b. Clear? So if the value is 0 comma b, so it will be, we have to put 0 comma b on the equation 2. So in the equation 2, we have to put the x value as 0 and y value as b. So if you substitute the x value 0, it will be b square plus y value is b, that is b minus half whole square a square minus a square b square. Fine. So if you substitute this value on the equation 2, you will get the initial decision parameter P0 is nothing but b square minus b a square plus 1 by 4 a square. So how we are getting it? Let us say it is equation 5. How we are getting this equation 5? We are substituting 0b in equation 2. Okay, so we are substituting 0b in equation 2. We are getting the P0. Fine. So we have P0. So if I know P0, so let us say we know PK. Okay. So as we know PK, we can compute the P of K plus 1. So how we can compute? We know the value of PK. So if the value of PK is greater than 0 means the midpoint, this midpoint is outside of the circle. So the midpoint is outside of the circle means if I choose the value yk, that means we are pushing the points far away from the boundary of the ellipse. Clear? So what we have to do? We have to take the points closer on the arc of the ellipse. So we have to decide yk minus 1. But if the midpoint, so okay, first complete this one. So if pk is greater than 0, my k value for the y value for the k plus 1th iteration will be yk minus 1. So if the y value is yk minus 1, then x value will be xk plus 1. Fine. So what is the points we have to illuminate? Which pixel we have to illuminate? We have to illuminate x of k plus 1 and then yk minus 1. This point I have to illuminate. Clear? Now if you put this point on the equation 4, if you put this point, so put it in equation 4. So if you put this point in equation 4, what you will get? You will get P of k plus 1 is equals to Pk plus, so what you can, how you can getting this point? You have to replace the xk plus 1 will be as it is. So y of k plus 1 will be yk minus 1. So it will be Pk 2b square x of k plus 1 as it is. Y points will be yk minus 1 whole square minus this one, then a square, and this one will be yk minus 1 minus yk a square. Okay, make it clear. So what we are doing, we are just substituting the point, we are just substituting the points on this equation 4, and we are getting this one, and then it will be b square. So now if you just cancel the terms, positive negative terms, you will get the value of pk plus 1 is nothing but pk plus 2b square x of k plus 1 minus 2a square y of k minus 1. Rather write it, better to write it, instead of writing yk minus 1, I can write y of k. Basically what you will get this one, basically. Okay, you will get this term. yk minus 1. So instead of writing yk minus 1, you can write the substitute also yk minus 1, then plus b square. Okay? Plus b square. So this is the equation you will get if the value of pk is greater than 0. So this is the equation which you will get if the value of pk is greater than 0. So say what is the previous equation number 5. So say this is the equation number 6. Now again, if the value of pk is less than 0, that means the midpoint is inside this ellipse. If the midpoint is inside the ellipse, in that case, midpoint is inside the ellipse. So in that case, we have to say which point we have to select, yk or yk minus 1. So this point is inside the ellipse. So if you select yk minus 1, that means you are again going far away from the boundary. What we have to do? We have to push the points towards the boundary. So we have to select the yk. Fine. So if pk greater than 0, I have to select yk. That means y of k plus 1. That means the k plus 1th iteration, the y value of k plus 1th iteration will be yk. So if this is yk, I have to again find out p of k plus 1. So p of k plus 1 is nothing but, if you substitute this, so what the x value we will get? X value will be x of k plus 1 and y value will be yk. Fine. So if I put this point on the previous equation, if I put this point on the equation 4, so what I will get? I will get p of k plus 1 equals to pk plus 2b square xk plus 1 plus b square. Okay? So that means pk plus 2b square, you can say it, we can write it at xk plus 1 plus b square. Fine. So this is another equation which will be used to generate the points for the region 1. Okay. So that's all for the today's lecture. So far I discussed is the how to generate the points on the region 1 of the ellipse. So I have discussed, I have shown you how to calculate the decision parameter, because based on the decision parameter we will compute the points on the region 1. Now in my next class, what I will show you, I will again compute the decision parameter for the region 2. Fine. So now after finding the decision parameter for the region 2, I will show you how to write down the algorithm and solve the problem so that we can generate the points on the ellipse. Okay, so I think it is clear to you. So in my next lecture, I will give you the very brief description that how to find out the points from the region 1, and then I will show you the derivation of the decision parameter of the region 2. Fine. So watch my next class, and thank you for watching this video.